Are you seeing screen?
Uh, yes.
Okay. So it's paper number 42, May June 2020. Okay. So we will solve it. First question. First question says that figure 1.1 shows the speed time graph of a person on a journey. Okay. On the journey, he walks and then waits for a bus. Okay. He then travels by bus. He gets off the bus and waits for 2 minutes. He then walks again. His journey takes 74 minutes. Okay. As you can see here, same thing I've
Yes,
done
yes.
on the graph. Okay. For the whole journey, calculate the distance traveled. How much distance he have traveled. How you will calculate it?
Distance is normally do distance equal to speed times time.
Okay,
So then first we add all three of them up.
okay.
So we do 5. So 5 divided by 20 times 6. So 5 divided by 120
How 5 divided by 120? What is 120?
because wait, no. Uh
We will calculate it by using graph, and graph have three sections. So we will calculate distance for each section, and then we will add up. Okay.
so yeah, so we'll do 5. 5 is kilometers per hour divided by um divided by how many minutes? 20 minutes. So you do 20 divided by 60.
Let me tell you how we will calculate. First, we will solve it for this section. So in this section, speed is 5 and time taken is 20 minutes. So for this section, S means distance will be 20 times 5.
Sir, but then this time is in minutes and the speed is kilometers per hour.
Oh, that's why you are doing dividing. Okay. So speed is in kilometer per hour. So for calculating in mm, time is in minutes. So what we will do?
So 20 minutes in hours, you divide by 60.
Okay, so
So we
tell
get
me
zero point 0.3 recurring.
how much distance for first part?
Uh, 15
15 kilometer
kilometers.
for first part section,
Ah,
first section.
ah, yeah.
Okay, 15 kilometer. Then for second section.
20 minutes again, 0.3. So I can't see the top.
Okay, here it is at 40.
So that's 40. So 40 divided by, no, 40 times. It's
40
times,
time,
yeah?
yes, 40 time 20 divided by 60.
So, sir, I was wrong about the first part. It wasn't 15, it was 1.6 something.
Can you tell me how you calculated it?
What I did, so then first I did 20 divided by 60 to get 0.3 recurring. And then
Okay,
instead of times, I divided. So now it was supposed to times. So you do that times by 5. We get 1.6 recurring.
mean you have done in this way. Let me take. Mean you are saying that you have taken speed as 5 and multiplied with times 20 by 60. In this way you have done it.
Yeah,
Okay, so what is the answer?
1.66666 recurring.
Okay, 1.67. Okay, so what for second section? It has speed 40 and
40
Time
times by
is
0.
20 minutes.
We get 13.33333.
Okay, second distance is 13.3.
3333.
Okay, very good. Then what about for third section?
Third section is 52 to 74. That's we do 22 divided by 60, 0.3666. So then we do 6 divided by 0. We get 16.36.
16 point.
36.
Have you done it rightly? Check it again because I think that you have. I think you have done some mistake in this part, in this section. Let me make it.
74 minus
Let me
52.
zoom it. So no.
50, so 74 minus 52 is minutes. So we get
Yes.
22 minutes
Okay, 22 हो गया.
divided by 60.
Okay. Multiplied by.
We get 0. Multiplied by 6.
Okay, 6. Then what is answer?
2.2.
Yes, this is the right answer. 2.2. So you will add all these things. So add all these distances and it will give us the total
We
distance.
get 17.17.
So it will be 17 kilometers. Is it okay?
Huh.
Okay. So next question is about what is the average speed of this person?
So average speed. So they travel 17 kilometers in 20,
74
in
minutes. Time
40
is,
in 62 minutes. Oh yeah, 74 minutes.
by the way, we will use 62 or 74. Which we will use?
I think we use 74 because it says average.
Yes, because his whole journey takes 74 minutes. Okay. Then what will be the answer for average speed?
Distance divided by time. 74 minutes. So then 74 divided by 60. 1.23. And then 17 divided by 1.2. 13.9 kilometers per hour.
Have you done it? Can you repeat?
I did 17 divided by 74 over 60.
Okay, very good. Mean you use this distance and time taken. You have use the time 74 minutes.
Yes,
Okay, very good. What is the answer for average speed?
13.9 kilometers per hour.
13.9 kilometers per hour. Okay, very good. No, next question. Next question says that state and explain which feature of the speed time graph shows acceleration. Speed time graph.
That is acceleration because acceleration is change in velocity of change in time.
Okay. But he is asking about which feature tells us that this graph is showing acceleration.
Gradient.
Yes, it's gradient. So gradient of the graph shows the acceleration. Okay, very good. State and explain the acceleration of the person at time 40 minutes. So first see the what is distance acceleration at time is equal to 40 minutes.
So 40 minutes, it is at 40. So acceleration is 40 divided by 60 times, no,
You are missing
that
one thing.
40
You
divided
are
by
missing one.
0.6.
You are missing one thing. Is that at time 40 minute from 30 to 50 minute the speed is constant, which is 40. So speed does not change. Then if the speed is does not change, then what is the acceleration?
Oh, zero.
Yes. So acceleration here will be zero. Okay. Okay, next question.
Okay, okay.
Next question says that figure 2.1 shows a train. Okay, as you can see, the total mass of the train and its passenger is 750,000 kg. Okay, this is the mass of the train and passengers. The train is traveling at a speed of 84 meters per second. The driver applies the brakes and the train takes 80 seconds to slow down to a speed of 42 meters. Mean this was the initial speed, this is the final speed, this is the time taken. Okay, no. Calculate the impulse applied to the train as it slows down. How you will calculate impulse? First, tell me what is the impulse?
Impulse is change in momentum, so
Yes,
I equals mv.
very good. So here
So
you
then
have
we do final.
final velocity and initial velocity. So your impulse will be how you will calculate.
So you do 42 minus 84
Very good.
divided
42.
times by 750,000.
Very good. 750,000. Okay. Then what will be the answer?
Uh, minus 42. So we just take the positive number,
Okay.
which will be 3 times 3.15 times by 10 power 7.
Very good. 3 point. You can write it 3.2 times 10 raised to the power 7. And what is the unit for impulse? It's Newton second. Okay.
Newton seconds.
Okay.
Huh.
Very good. Next question says that the calculate the average resultant force applied to the train as it slowed down. So here you have to calculate the resultant force F. How you will calculate?
F equals ma.
But A is not here.
We calculate a.
You can solve this it by this way, but you can use the above question. Here you have calculated. Why are you not using the second form of Newton's second law, which is equal to F is equal to change in momentum per unit time. So here you have calculated impulse. So you will divide it with time.
Oh, okay, 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 okay.
Is it okay? Because this is impulse. Impulse is
Yeah.
change in momentum. So you have calculated in the above part that change in momentum. So you will just divide it with time. Time is 80 seconds. So for your force, it will be 3.2 times 10 raised to the power 7 divided by 80. So it will give you the resultant force. So what will be the answer?
400,000 newtons.
400,000 newtons. Very good. Okay. The way you are going to solve, you can use that way. The way is also correct, but it may be lengthy one. Okay.
Huh.
Okay. Next question says that suggest how the shape of the train helps to travel at high speed. So how shapes helps? How shape will help?
Uh, it is streamlined.
Yes, it is streamlined. Then what will happen?
Uh, if it's streamlined, then what's it called?
Because the shape is streamlined, so it will reduce air resistance. Okay.
Yes, sir.
Okay. Next question says that the train took 80 seconds to reduce its speed from 84 to 42. Okay, explain why with the same braking force. The train takes more than 80 seconds to reduce its speed from 42 meter to 0. Why?
This is because
Because the reason is that when
momentum is reduced.
what momentum? What have momentum to do with time to stop?
Or not.
Actually, reason is that when the train was changing speed from 84 to 42, then there was a high air resistance because it was at high speed, so air resistance was also high. But when the train is moving from 42 to 0, then the air resistance has decreased to much amount. That's why now it will take more time than 80 seconds. Okay,
Uh,
have you got this thing?
huh.
So there is less air resistance at lower speed. Okay. Next question says that on a wet day, the train travel a greater distance before it stops along the same track. The train has same speed, 84 meters per second before the brakes are applied. Suggest a reason for this.
A wet day means there's less friction,
Yes,
and so less friction means there's less forces. There's less resultant forces on the train, and so it travels a greater distance.
very good, very good. Wait a minute, wait a minute. Okay, you have told the right answer. Okay, next question. Next question says that a solar panel receives energy from the sun at a rate of 5 kilowatt. Okay, the thermal energy is transferred from the solar panel to the water with an efficiency of 20%, 20%. Cold water of mass 5 kg into to the solar panel every hour. Okay, the specific heat capacity of water is 4200 joule. Calculate the temperature increase of the water. How you will calculate temperature increase?
Uh, 20%
Okay.
is
For your help, you will use this formula, this which I have written. How
output
then?
of an input.
Yes. Then how you will calculate output energy and input energy?
First, you just find out energy.
Okay.
So we've been given power, and we've been given time
Okay. You have
because
given
there's every
time,
hour.
power, specific heat capacity, mass, and efficiency. These five things are given.
So then first we find out energy. So we do 5,000 watts
O-
times by 3600.
Okay.
So when we get 5,000, let me do it. 5,000 times by 3600, we get 18 million. And then now this is our energy. So then we do zero point 0.2 times by 18 million. So 3.6 million is our thermal energy,
Okay. Then either this is input energy or output energy.
output energy.
Okay. This is
So
output
output
energy.
energy is three. So we can output energy is 3.6 million. So then
Okay. Let me
we
write. Let
then
me write.
put this.
Let me write. Output energy is output is what? 3.6 million.
Huh.
Okay. It's 3.6 times 10 to the 6. Okay, this is output. Then what is input energy?
Input energy is
The,
18 million.
how?
No, so it's the other way around. We put in like our total energy is 18 million, but thermal energy itself is just 3.6 million.
Okay. Should I solve it?
So I think I can solve it. 1 second.
Okay, okay.
So then, for thermal energy is 3.6. So we use the specific heat capacity formula. to find delta T. So we do E divided by C and M. So 3.6 million divided by Cm. Cm is 4,200. 4,200 times by 15. 63,000. 63,000. So then we do divide by 63,000. So our change in temperature is 57 degrees Celsius.
50,
7.
57. Mm, let me check. Okay, now you repeat the steps you have taken. Then I will tell you you have done it right or wrong.
So firstly I did to get energy I did power over time.
Power over times or power multiplied by times.
Oh, yeah, sorry, power multiplied by times. So I
Okay,
did
you have
5,000.
multiplied these two things. These two.
Yeah,
Okay,
5,000
and
times by
it has given
36.
you out input energy or output energy.
Input energy.
Yeah, so it's your will be input energy. And for what you have used for output energy or what formula you have used.
So I did zero point 0.2 times by 18 million to get 3.6 million for
From where you have got
output
18 million?
energy.
From where you have written 18 million? From where?
From get the energy that we got from 5,000 times by 3,600 is 18 million. That's the input. That's the total.
Okay, wait a minute, wait a minute. Okay, repeat again. What are you saying that?
I'm saying that
Okay,
I did 5,000 times
okay,
3,600
you have
to get
found
18 million.
found input energy. And what was the answer for
Huh,
input energy?
18 million.
18 million. Okay, time 10 to this was your input energy. Then what you
Huh.
have done next?
I did 20 over 100 times
Okay,
by 18 million
okay, time very good. Okay,
to get 3.6 million.
okay, very good. Mean you have got output as 3.6 times 10 raised to the power 6 joule energy. Okay,
Six.
then
Yeah.
how you have calculated delta T or change in temperature?
So I use the formula energy is equal to specific heat capacity times by mass times by delta T. And to find delta T, I did energy divided by specific heat capacity times by mass.
Very
So
good.
I did
Okay,
3.6 times 10 power 6 divided by
very good.
15 times
Okay,
4,200.
okay, okay. You have done rightly. Okay, let me just write the steps for better. Mean you have written efficiency equal to output energy you use formula MC delta T, and for input energy you use formula PT. Am I right? So for
Yeah.
delta T you have multiplied 0.2 times PT, and PT was input energy which was 18 million, 18 million, and then you divided it by MC. So M was 15 and C was 4200. Am I right?
Huh.
Okay, then what was your final answer for temperature?
57 degrees Celsius.
Very good, very good. It's okay. So now move to the next question. Next question says that state and explain one advantage and one disadvantage of heating water in a solar panel compared with the heating water in a coal burning boiler. What is advantage?
Advantage is renewable and
Okay,
it can be made over and over again. And disadvantage is that it's expensive.
expensive and cannot be used at night because sunlight is not available at night. Okay.
Huh.
Okay, next question says that figure 4.1 shows the liquid in glass thermometer with without a temperature scale. The liquid inside the thermometer has a melting point of 39 degrees centigrade. Okay, this is the melting point. Okay, now describe the simple experiment to mark the position of the fixed point on this liquid in glass thermometer. So what? method you will use for marking the lower point and highest points?
Sir, our school physics teacher said thermometers have been removed from our syllabus.
Okay, okay. You mean you are saying that we should not solve this one? Okay,
Yeah.
okay, okay, fine. So we will skip this part. Okay, next question. Next question says that figure 5.1 shows a crust of the wave approaching a barrier where the wave is reflected. Okay, here you can see a wave is approaching toward the barrier and it will be reflected. Okay, on figure 5.1, draw the three crusts of the reflected wave. So it will be the same. They will be in this direction at 90 angle. So you can draw it in this way of same wavelength. Is it okay?
Chips check highlight.
Yes,
Next
sir.
question.
Sir, I don't understand. Could you explain?
I because the wave is reflected. So whenever the wave is reflected, then the angle between incident wave and reflected wave must be 90 degrees. So if I expand in this direction and it will be in this direction, then this angle will be 90
So
degrees.
what if
So
it's refracted?
refracted.
What if it is refracted? Just in
If
case the
if
question comes.
oh, okay, okay, no issue. If it is refracted, let me. So if it is refracted, then angle of incidence must then you can let me. Then you will first draw the normal. Okay. First you will draw normal. So this will be your angle of incident. So if the this will be the angle of incident, then it will depend upon the medium on the other side. If it is a denser medium, then it will bend in which direction? Away to the from normal or towards normal. If it is a denser medium, moving
Away from.
from rare to denser medium.
It'll go away from the medium,
Yes,
from the
so
lower.
it will bend in this way. It will move in this way. Okay, mean angle of reflection will be
Huh.
larger one, and now the crust will remain same. Is it okay?
Yes, sir.
Have you
Huh.
got the answer for refraction and reflection?
Huh.
Okay, so for reflection, this would be in this direction, in this way. This is for reflection, and this is for refraction. Okay. Now move to the next question. Next question says that the wave has a wavelength of 36 centimeters, okay, and a speed of 1.2 meter per second. Okay, calculate the frequency of wave. How you will calculate? Which formula you will use?
V equals F lambda.
Okay, F lambda. But what is the which will use 36 as such, or you will first convert it into the meter?
Oh, I'll convert into meters.
Yes, okay. You will use formula V is equal to F lambda. So for frequency, you will use V over lambda, and V is 1.2 divided by 0.36, and it will almost give you the answer 3.3 hertz. Is it okay?
Huh.
Okay. Next question says that this is about the filling the blanks. Complete the following sentence. An echo is the name of a reflected sound wave. This is a simple one. The wave that from an echo are a type of the longitudinal waves. Longitudinal waves are made up of compression and rarefaction. Simple thing. These words. Is any confusion in these fill in the blanks?
No.
Okay. Next question says that the figure 6.1 shows an arrangement of glass prism inside a box. The angle of the prism are 45 degree, 45 degree, and 90 degree. Okay, mean he is saying that this angle is 45, this is also 45, and this angle is 90 degree. Okay, so now move to the question. Question says that this is a device used to view the object that are behind a wall. Okay, the incident ray of light undergo total internal reflection in the prism. On the fixed 6.1, complete the path of the ray, the device, and show the ray is it emerges out from the box. Can you draw, or you can help me how? We will draw.
Uh, it's reflecting
So it's reflected. It means it will go. Let me draw. So it will go.
perpendicular.
Yes, it will go here, and from this it will go in this direction, and it will go here, and from this it will go in this direction. Is it okay?
Huh.
Okay. Next question says that show that the refractive index of the graph with a critical angle 45 degree is 1.41. How you will calculate it or how you will prove it?
So we do n equals 1 over sine c.
Very good. We will use n is equal to 1 over sine c. So very good. What over sine 45 degree? So it will give us the value 1.41. Very good. Okay, now move to the next question. Next question says that a student makes up a transformer that uses an alternating current AC current supplied with an electromotive force. Mean this is the input supply. Okay, to induce
Huh.
an output potential difference of 2 volt. Mean this is VP and VS are given. The student is provided with two lengths of the insulated wire and a U-shaped piece of the iron. Okay, as shown in the figure. Complete and label the figure 7.1 to show the transformer connected to the supply and output from the transformer. Can you help me to draw?
We draw coils on each point,
Yes.
and if it's a we need to see if it's a step up or step down.
So first see from question. At input you have
It
12
goes
volts
from
and it's step up or step down.
it's step down, so the right one will have less coils.
Yes, right side with it. And here you have connected an AC source. This is the symbol for AC source. You have connected with this one and on other side and there is a nothing, there is dust. So this is your primary primary coil and this is your secondary coil. Okay.
Huh.
Okay, next question. Explain the function of the piece of the iron in the transformer. So what iron do here?
Uh, the iron, what's it called? Conducts the electricity.
Yes, iron. No, it does not. Uh, actually, iron produces the process of electromagnetic induction. Mean the magnetic field being produced in primary coil, and iron is linking this magnetic field with the with secondary coil. And in this way, when the magnetic field lines cut the coil in the secondary coil, then an electromagnetic induction happens here, happens in the secondary coil. Okay, and it causes
Yes,
better
sir.
induction, okay, because it's conductor. Next question says that the output of the transformer is connected to a lamp, okay. The current in the lamp is 100 milliampere. The efficiency of the transformer is 100 milliampere. Calculate the input current of the transformer. How you will calculate it? By the way, this 100 milli is this input current or output current? I1 or I2?
Uh, I1 is input, I2 is output.
So this 100 milliampere is input or output?
It's in it's
First, see the figure.
output.
Yes, here is the lamp. Here is the lamp connector. So it's at output. Okay. So it's output. And what is the voltage at output? It is 2 volt. Okay. And what is the voltage at input? It's 12 volt. And you have to calculate the current at input. Okay.
Huh.
So input voltage is 12 times I1 equal to 2 times 100 times 10 raised to the power minus 3. Okay, for I1 it will be 200 times 10 raised to the power minus 3 divided by 12. Can you tell me the answer for I1? 200 divided by 12.
I1 will be uh
You just divide
let me
200
do it.
by 12.
Just 200, not times 10 power minus 3.
Because it will give you milliampere. So leave the 10 raised to the power minus. Just divide 200 by 12.
16.67.
So 16.7. You can write 16.67 milliampere. Is it okay?
Huh.
Next question says that another transformer is used in a school laboratory to step down a main supply with a potential difference from 110 to 12 volt. Mean 110 is VP and 12 is VS. This transformer is mounted in a metal case. State and explain an essential safety feature required for this arrangement. So what you will safety feature you will do here?
Um, we can use me- uh what's can we use an earth wire?
Yes, metal case should be connected with an earth wire. Why? Because if the wires fall with each other or and insulation of the wire fails or burn out, then in this way it will not touch the case or if it touch then the current will pass through to the ground and the person will remain safe. Okay.
Huh.
Okay. Next question says that a light emitting diode (LED) is a diode that emits light when there is a current in it. Draw a circuit diagram showing an LED connected so that it in series with a battery and a fixed resistor. Use standard electricity symbols. So, how you will draw it?
Light emitting diode is it's the one where it's the one direction one.
Yes, it's diode. So, if the bat this is the P side, this is N side. So, its P side of this diode will be connected with positive terminal. So this is the P side will connect to the positive terminal and N side will connect to. And here you will use a resistor. Okay, here will be the resistor and this is the symbol for LED diode. Okay, here you will draw three arrows going outward. Okay,
Huh.
is any question here? Is any question in this figure or diagram?
No sir.
Okay, next question says that the potential difference across the LED when lit is 3 volt. Mean here the potential is 3.1 volt and the current in LED is 0.030 ampere. Okay, calculate the value of the resistance of LED when lit. How you will calculate R? Mean resistance of the LED. So voltage is given, current is given, simple Ohm's law V is equal to IR. So R will be equal to V over I. So
I
what is V? V is 3.1, I is 0.030. So just give me the value of resistance.
uh 3.1 divided by 0.03. 103.3.
103. Have I
So
written?
100 and no, like 103. 103.
Okay,
103.
okay, 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 okay. 103. 103.3.
Huh.
Okay, very good. Next question says that, yeah, this is the figure. Figure shows a power supply of EMF 10.5 volt. Okay, here is a power supply connected in series. This is the power supply. Its voltage is 10.5 volt. Okay, connected in series with a lamp. This is a lamp. Okay, and a heater. Lamp and a heater. The potential difference across the lamp is 2.1 volt, and the current in the lamp is 1.5 ampere. Mean this is the lamp. Here the voltage is 2.1 volt, and current here is 1.5 ampere. Okay, and this is the heater. You can call it heater. This is the heater, and here you have a battery connected of 10.5 volt. Okay, so
Huh.
now move to the question. Question says that resistance of the calculate the resistance of heater. So how you will calculate it?
Resistance. So we have potential difference.
First you will calculate the potential difference for heater. So how you will calculate potential difference for heater?
10.5 minus 2.1.
2.1 or 1.5? Oh, sorry, very good. 2.1. Very good. 2.1. Oh, yes, 2.1 is potential difference. Then potential voltage for heater. What is the value? 10.5 minus 2.1.
Uh, it's 8.4.
8.4 voltage. Okay. And what is current in this heater? Because it is connected in series, then current remains different or same.
The current remains the same
Very good. Okay, current will be
because
2.1.
it's a series.
Okay, then what will be R? R will be same formula as for the last question. So V over I, V over
Huh.
I. So 8.4 divided by 2.1. So what is the value?
4.
What is value 4?
Huh.
Mm, let me check. Okay. Now move to the next question. Says that the power of the heater. So what will be the how will be the what will be the power?
Power is we can do P equals IV. So
Very
current times by voltage.
okay. What is the answer? 8.4 times 2.1. So what is the answer?
8.4 times 2.1. 17.64.
17 point. Achha, by the we are doing some mistakes because the resistance, the answer for resistance must be 100, and then after that, because here we are doing some mistake. First, read the question again in detail. Uh, Figure 8.1 shows a power supply, okay, of EMF 10.5 volt connected in series with a lamp, okay, and a heater. Okay, the
Huh.
potential difference across the lamp is 2.1 volt, and the current in the lamp is 1.5 volt. Okay, okay. Then calculate the resistance of heater. So it was initially was 10.5 volt, 10.5 minus 2.1. It was 8.4. Then current remains. Oh, we have taken current. I think wrong. Current is 1.5 ampere. not 2.1.
Current is, huh? Oh, we divided by the wrong. Huh. But
Current
then,
is,
how do we get 100?
yes, I am thinking the same thing. How we will get 100? Because in the mark sheet, it has the answer 100. Acha, calculate what is power. Just multiply it by 4 times 1.5. What answer it gives?
Which one?
8.4 times 1.5.
0.4 times 1.5. 12.6.
Okay, very good. So it's not 100. It must not be 100 because we the same things, same values give us the same answer. Right answer. It is 12.6. Then just divide 8.4 with 1.5. What is the answer?
Uh, for what?
8.4 divided by 1.5.
5.6.
So it will be 5.6, not 4. This is the right answer. 5.6 ohms. Okay, and power will be in watt. Okay. Now next question. Next question. Complete the truth table in the table 9.9 for NAND gate. Inversion of AND gate. So 0 0 it will be 1. Let me help you to calculate the next one. What will be 0 1 0? It will be 1 1 0 0. It all will be also 1 1 1 1. It will be 0. Have I done right?
Yes, yes, because NAND is opposite of AND.
Yes, very good. Okay. Next question says that the circuit shown in figure 9.1 contains two different type of the gates labeled X and Y. Here you can see two gates X and Y. Okay. The table 9.2 shows a partially completed truth table for this circuit. Okay. Here we have two
Huh.
inputs A and D. So C is the output of X. So first analyze C. 0 0 0 0 1 1 1 1 1 1. So what is X gate? What about X gate?
X gate, it takes what it gets from C and D. So then if C is a X is a what gate?
It's simple OR gate. It's just adding the things. Zero
Oh yeah, it's
zero
OR
zero.
gate.
Yes, because output is C. So C, you can see the column C. So 0 0 0 0 0 1 1 0 1 1 1 1. So it's OR gate. Okay,
Huh.
this is OR gate, and this is also this also will be OR gate. Second X,
So
it's
then
also OR gate.
second X. So we're trying to find second X. So D is a AND gate. So then
Yes, means you are saying Y would be AND gate.
yeah, why would be AND gate?
So it will be AND gate. How you identified it?
Because all of them are zeros except when both of them are one.
Okay, very good. So Y is AND gate. So add X again at when C and D are inputs. Wait a minute, wait a minute. Far no kuch talk de beta. Hello.
Hello?
Acha. So I am saying that X is again R gate. So what will be in output at E?
Uh,
We will use C and D. V as R P chakre
so we don't know what gate the other. Oh, it's the same one. It's OR. So
Yes,
then we
it's
use
R.
C and D. So it will be zero, and the rest of them are ones.
1 1 1. Very good. Okay, you have done right. Next question. From table 2 9.2, deduce the name of the logic gate Y. So what was the name of the logic gate Y?
Logic gate Y was a AND gate.
So it was AND gate. Very good. Next question says there is a circuit. No, there is a current 3.3 ampere in a copper wire. Calculate how many electrons pass through the copper wire in 60 seconds. Mean time is given, current is given. The charge on one electron mean charge on one electron is also given. So we have to calculate number of electrons. So how we will calculate?
Uh,
First
you can
we will use
calculate.
the formula of current. So what is the formula for current?
Um, Current formula for current.
Yes, current.
We have P equals IV, V equals IR, Q is equal to IT.
Yes, Q is equal to IT. So you will use this formula. Q is equal because here Q is given, T is given. Okay.
Huh.
So first you will find Q. So Q will be IT. IT. So I is 3 and time is 60. So it will be 180. 180 coulomb. Is it right? So
Huh.
for number of charge, you will use this formula. Q is equal to Ne. What is N? N is number of electrons, and E is the charge on one electron. So for N, you will just divide it with Q. So Q over E. So what is Q? Q is 180. 180 divided by 1.6 times 10 raised to the power minus 19. So just divide it 180 by 16. What it gives you?
Uh,
180 divided by 16.
180 divided by 1/6.
Yes.
11.25.
11.25. So you can write 1.1 times 10 raised to the power 20 electrons. Is it okay?
Huh.
Okay, very good. Now move to the next question. Next question says that figure 10.1 shows a vacuum tube with a radioactive source. Okay, the radioactive source emits alpha particles, beta particles, and gamma particles. There is a strong magnetic field between N and S poles of the magnet. Here you can see S and N pole. Are you seeing on the screen?
Huh.
Okay. So the lead the lead cylinder has a narrow central hole. Okay. State and explain the effect of the lead cylinder. What will be the effect of the lead cylinder? How or why we use lead cylinder here?
Because we use lead cylinder because it is the only thing that can stop alpha and beta particles.
So it will absorb all the radiation going in all the directions. So we will get only the rays in one direction because it will absorb all the rays going in other direction. Okay.
Yes, sir.
So beam will become narrow and straight. The radiation in the other direction are absorbed. Okay. Next question says that describe the path of alpha particle, beta particle, and gamma as they pass through the magnetic field. Explain your answer. What will be the path of alpha particle? So in which direction they will move? Here, let me give you a hint. Here you will use Fleming left hand rule.
Huh. Oh, this is motion, this
Yes.
is magnetic field, and this is current.
Okay.
Ow. So do we use the left hand or the right hand?
Left hand, left hand.
Or I left. So for left hand, path of it is going up.
Yeah. Out of the page means towards observer. Okay. Or toward
Yes, yes.
reader. Okay, so it of the out of the page. Why? Because the Fleming left hand rule because it is equivalent to the current in the direction of beam. Okay. What about for beta particle? It will be opposite direction because beta particle have opposite charge to that of the alpha particle. So if the alpha particle are given outward, then beta particle must go inward into the screen. Okay, or
Huh.
into the page. So because it is equivalent to the current in opposite direction to the beam. Okay, next. What about gamma particle? In which direction gamma particle will go?
Gamma particle. Uh, if it's like this, so it will go. downwards.
Why? What charge gamma particle have?
Because gamma particles have because since what's it called, when alpha particles have a proton, they go to one side, and the
Beta have
charge on a
electron.
gamma particle,
What is charge on gamma particle?
gamma is negative.
Why not? Gamma is neutral. Gamma has no charge. Gamma rays.
Oh, yeah, yeah, yeah. Alpha is positive, beta
Beta is
is
negative
negative,
and
and
gamma is neutral. So it will go straight. Okay.
huh.
So go straight because they are uncharged particles. Okay. We have also done with this paper. Any question?
No, sir.
Okay. Now you want to revise space part of your book.
Yes.
Okay. Give me some time. First, let me go through from the book and then I will text you to take the class. Okay.
Okay, sir.
Okay. Bye bye.
Bye, sir.